In the name of God and hi to all the students, good time and I hope to be fine. As we said in the previous sessions, from this session we want to discuss and study a new topic. It is related to neural network, and then after that convolutional neural network and learnings. Our reference at first in this topic is Rashid. As you see here, I uploaded this in the LMS, and if we attention to the content of this book, at first said about the concept of classification, training, and then step by step we will arrive the neural network. Okay, then after passing some pages, it first said that I try to explain. Let me enhance this voice. At first, in the beginning pages said that some processing is easier for human, and some of them is hard for humans. For example, doing some mathematical formulation is more easier for computer comparing with human, but recognizing the faces and the number of faces in the pictures is more easier for human. Okay, then said that when we have a question, when we ask a question from a human, he or she thinks and then prepares an answer. Okay, and in computer, when we have input, then the computer do some processing or calculation, and then according to this processing we will see the output. For example, if we have 3 multiplied by 4, it calculate by the summation, and we will see the 12. Sometimes we have input and we have output. What we don't know, how we calculate, and what is the exact relationship between the input and output. For example, here we want to transform kilometers to miles. First, consider and imagine there is a linear relationship between kilometers and miles. For example, as you see here, miles is equal to kilometers multiplied by c. C is a constant. And by programming, by guessing, we want to know this c to calculate and transforming kilometers to miles. The first said that if you know some two pairs, some examples of this transforming, for example, 0 is 0 and 100 kilometers in mile is 62.137. Okay, we know these true and correct pairs, and using this example we want to guess and achieve the correct C, the linear constants between input and output. For example, at first, we consider C is equal to 0.5. Then in this way 100 transforms to 15. But we know the correct answer, the true answers, and if we calculate the differences between the true answers and the calculate answers, we see that there is an error between them, and it is now, with this constant, it is now around 12. Okay, and here you see the diagram here and calculate the error. Then in the next step, we try to have lower error. Then we try increase this constant to 0.6, and then the calculated, in this way the calculated miles is 16, and on the other hand the correct miles is 62.137. Then the error between these two numbers is around 2. Then again we continue our processing to achieve a new C. Then we change it from 0.6 to 0.7. Okay, in this way our calculated miles is 17. On the other hand, our correct miles is 62.137. Then the differences in this way is minus 7.800 blah blah blah. Okay, then now as you see, when our error is minus, by calculating the correct value minus calculated value, when we have a negative error, we said that it is we have overshoot, and it is not good for considering these constants. I mean 0.7 is not good for this example. Then 0.6 is better than 0.7, but we can change C a little, and we can convert 0.6 to 0.61. In this way, our calculated miles is 61, and comparing to correct miles, the error is 1.137, and this error is less than the previous one if you compare with 0.6. Okay, then this is okay, and it is better for us. Then totally we can say our key points is all useful computer systems have an input and output. Yeah, it is true. With some kinds of calculation in between. Yeah, neural networks are no different. Said that neural networks are like this. Okay, when we don't know exactly how something works, we can try to estimate it with a model which includes parameters which we can adjust. We guess something, and then comparing the calculated values and the correct one, we step by step update this model. And as you see, a good way of refining these models is to adjust parameters based on how wrong the model is compared to non-true examples. We have this example. Now as you see in the previous example, and if you pay attention, it is like a predictor because it takes an input and makes a prediction of what the output should be. What is the prediction? The prediction is according to the correct value. Then according to that, the system trains and learns how to found the concept. Okay, now you consider a garden, and we have many insects in it. For example, caterpillar and ladybirds. Caterpillars is this, and ladybirds is this. If you don't know, you can see the images here. Okay. Then the size of them are completely different. If we consider the width and the length of these objects, the width of ladybirds is larger than length, and in converse, the lengths of caterpillars are larger than the width. Okay. Now we want to classify these two groups. This blue line, it is clearly that it is not good. And then this line again, it's not good. Please attention to the slope of this blue. The slope of this blue here is less than here. The changes are higher than the slope is larger. Totally none of them is good, but this is very good, and our desired line is like this. Okay. Now again consider if this line is the line of the classification, and we have this object, we don't know its type, but if we consider measure the width and length, we can put this object in this class, in caterpillar classes. Okay. Then totally the question here is that how we can find this blue line. Okay. Again, we using some measurements, we try that the system, the computer, learns the objects. For example, the ladybirds width is 3 and length is 1, and caterpillar is in converse, the length is larger than this. For example, then the length is for caterpillar is 3 and the width is 1. Okay. Then in the diagram, the place and the location of these two objects according to ladybirds and caterpillar is in this location. Okay. Okay. And now we again because we consider linear classification, linear line, then we consider this equation: y is equal a multiply x, and said that okay, there is a linear relationship between width and length. Okay. For example, if you account for ladybirds, the x is for both of them. The x is related to width, and y is related to length. Okay, then we want to find this A. And in totally, the linear classification is like this, because in this equation the line passes the center of the coordinates, but here if we have a non-zero B, then the line can move to up or down. Okay, but anyway, like the previous, at first we consider and guess a number for A, for example here 0.25, and said that okay, the relation is here. And if we draw this line, this is like this, and if you pay attention, this is not good for us. Okay, then our desired is that the line is here. Okay, the linear line is here is greater than the letter bars. Okay, then we consider a higher value for y. But before that, again here we can calculate the error by this slope. A here is like a slope for this line. Okay, if x for ladybirds is 3, then the length is 0.75, but the correct one is 1. Then there is a difference between 0.75 and 1. Okay, then it is not good. As I said before, we consider our desired 1.1 with the input 3. Okay, then if our desired target is 101 and our actual output, our calculated output is 0.75, the error is 0.35. Okay, then now we want to find the correct line and correct slope, the better correct slope. Okay, and now again in this diagram you can see the error by this interpretation. Okay, this is our desired value, value of y, and this is our calculated value of y, and there is an error between these two lines. Okay. And we want to change this slope. Okay, then we add a delta A to A. Okay, we want to change this slope, and our desired value, our target is A plus delta A multiplied by x. Okay, and here, and delta A is positive. Okay, here we can see our desired line, our desired value, and this is the calculated value. The target we named it t, and our calculated are y. Then the error is t minus 1. We can calculate the error if we put the equations of t and y. Then the error is delta A multiplied by x. Then there is a linear relationship between the changes of slope and the error. If delta A is higher, then our error is higher. It is interesting. But if you attention from this equation, you can achieve to delta A, and delta A is equal to E divided by X. Okay. Now, according to the previous one, we calculate the E and the X, our input. Okay, error was 0.35 divided by 3, then delta A is this. Okay, and then our new slope according to the target, our new slope, change the slope. Okay, our new slope is this 0.25 plus this delta A is this, and it is very interesting that the y here is 1.1, and we achieve our desired value. Okay, it is so interesting. Now we test it with another example for caterpillar. For caterpillar, for input x with the value of 1, our output was 3. This width and it is length. Okay, and for this new slope, if we put in the linear equation, it said that y is equal to the new slope multiplied by the input, and it is this. Wow, it is so awesome, because the differences between the calculated and the calculated y and our correct is too high. It is around 2.6 around. Okay, it's around this error is too high, and we cannot accept this slope. Then again, what we can do? Again, according to the previous discussion, we can set that okay, delta A is equal to E divided by X. Then E here is this, and the X is 1. Then delta A is this, and our new slope according to the previous discussion is this. Okay, is the old A old plus delta A, and our new slope is 2.9. Okay, and now in this diagram we can see the summary of all of them. At first we guess this, and then according to mathematical equation we refine this to this. This line is good for this, but for this example is not good, and we again refine this, and then finally we achieve this linear equation, linear line for the classification of these two objects. Then you see that step by step we can find the usable line, and we in this neural network, in machine learning, we can say we can moderate the updates. Okay, we moderate the updates. It means that we update the slope. Okay, but according to other example, we moderate it, and it is better for all of them, all the example. Okay, and now we can consider another relationship, and as you see before, we see that this delta A, okay, in the previous pages we called it delta A. Now I called it delta A old. The new delta A, delta A is L learning rate multiplied by delta A old. Okay, and again we considered, we guess, a learning rate, for example 0.5. okay, according to the previous session, we, for example, at first we considered a 0.25, and then our y is here. We calculate the error, and again we said that our desired, if we imagine the desired 1.1, then the error is this, and now delta A new is equal to L multiplied by delta A old, and it means that after the calculation the delta A new is this. Okay, and our new slope is this. Okay, in this way for the input of 3 for ladybirds, then our output is less than 1. Okay, then it means that if these are ladybirds, the line is here, for example. Okay, because less than 1, then it is not good for us. This learning rate is not good for us. Okay, then we can change it. And according to the previous discussion again, please remember in the previous pages, in the previous slides, then the final value was this. Okay, now the final value was this, I mean in this image, our final refinement is this. Okay, then we multiply this by L, by learning rate. Okay, anyway, if we do this, and by calculating this, and we calculate by imagining this desired value, we calculate the error, and we calculate the delta A new by this learning rate, then our new delta A is 0.2, and our new slope is this plus delta A new. Then finally the new slope is this. The new slope is this. Okay? You must write it down in your sheet, in your own sheet, and step by step follow it in one page. Okay? Then the second moderated refinement is this. Why we call it the second? Because here is related to L E divided by X. Okay, and then after that we calculated the new delta A, and we consider the final moderation, and we moderate this line to this. And now you see that this blue line is better than the previous one. It is like here. This line is near to the data. Okay, but this here, this blue one is in the more middle between the objects and the groups, and then it is so better. Okay, then totally you see that you can use simple math to understand the relationship between the output error of linear classifier and the adjustable slope parameters. Really, it is so simple. We adjust the slope to remove the output error. The problem with doing this adjustment namely is that the model is updated to best match the last training example only. Okay, effectively ignoring all previous training example. As you see here, we forget the previous training. We try to update it to the data. And training example from the real world can be noisy or contain errors. And moderating updates in this way helpfully limits the impact of this false example. As you see, I explained about 34 pages. If you yourself study these pages, it is too simple. The feature of Rashid books is that the simplicity. Okay, so simple, so clear, and you can understand it well by simple sentences. Then please you yourself also follow and review these pages. The next session we will follow by a new example, and then we will achieve the neural networks. Thanks for your attention. Have a good time. Bye.